Hi, and welcome to another edition of Ordinary Differential Equations. Today we are going to continue our conversation about interval of existence. So let's go ahead and take a look at a few problems of this type. So we are going to focus on nonlinear equations. We want to find out the interval of existence for these. There is a theorem for these cases, but it's mostly theoretical. I would not be covering it. Rather, I'll go after a few specific examples and show you what kind of things could happen. So here are four problems, and we are asking for the interval of existence for each of these differential equations, assuming that the initial condition is given at the point 0. So at time t0, y is some y sub 0, and we want to give the interval of existence in terms of this y0. So the statement of the problem itself sounds very different from what we had last time. So in this cases, any of these problems, we want to solve it, find the interval of existence, and say how does it depend on y0. How is that such a contrast from what we saw last time? Let's go take a look at lecture from last time. So last time we had actually a simple theorem. We said you write your linear equation as y prime is equal to something times y plus something else, and then you go ahead and find the points of discontinuity of these and figure out where your initial condition is with respect to those points of discontinuity. From the point of discontinuity prior to this to the one after t0, that is your interval of existence. So you go ahead, locate where t0 is, you go find out next point of discontinuity and the previous point of discontinuity, that bracket t0. The answer is just the interval between those two. So for example, here we had a problem with y prime is equal to y tangent of t, and then the other function is t minus 1 over sine of t. We went ahead and found the points of discontinuity of these two functions, and to keep track of them, we put them on the real number line. That was easy. Then we go ahead and locate our initial time value. And then if, for example, initial time value is 1, then the interval of existence is from the discontinuity point prior to that to the discontinuity point after that. The answer did not depend on what y0 was. It just depended on which interval t0 was sitting in. And that's such a huge contrast to what happens with some nonlinear cases. Here we are from get-go, we are saying that our answer more often than not is going to depend on what the y0 is. So let's go ahead and solve a few of these things, and then also compare again to linear case. Before we dive down into all the algebra and the theory, let's go ahead and experiment with one of these things at least on our very useful software DField. See what kind of a situation are we dealing with. So for example, let's focus on the very first one. Y prime is equal to t2 y squared. So y prime, we are going to copy the first one, so it's 2 times t times y squared. Simple. We asked for the phase plane, so that's how the phase plane look like. So initial condition is given at time 0. This is where t equal to 0 is. So y is any of these numbers, so initial condition is any point of this line. So for example, if I pick this one, that would be the solution. Let's pick something else. uh, you might be suspecting that these things all go to the same vertical asymptote. They don't. Each of these solutions are limited by a different line. The line that limits this solution is different from the one that limits that one, and so on. Meaning if you expand your window, you're not going to see these lines coming close to each other. Here's a much more drastic display of the difference between the solutions here and the linear case. Suppose I come down here. Wow, you see the difference? The interval of existence now is all that looks like from minus infinity to plus infinity. Everything is a fair game. While if I'm up here, the interval of existence is very limited. We didn't see anything like this in the linear case. You remember the linear case of the solutions were packed inside some blocks, and once you are inside of that block, you cover it from essentially from top to bottom, and then the next set of solution can have a different block as their interval of existence. We never saw that if we go up and down, we are going to get different interval of existence. If you stay on a vertical line, your interval of existence does not change. So this is quite a different situation. So for y prime is equal to 2ty squared, we see a situation here where there is no limitation on the solution to the one here that there is. Another surprise is that for the linear case, we had a clue as to where things could go wrong. Over there, we said the problem is rather stares you in the face. If you have P and Q that become discontinuous, for example, if you have tangent of t and this thing with sine of t in the denominator, well, obviously, when these things reach their vertical asymptotes, you expect some problematic situation for y and y prime. More than likely they will also go to infinity if these factors go to infinity. But in the problem we are looking at right now, if I look at the right hand side, there is no denominator that's going to 0, there is no tangent or logarithm, anything with an asymptote staring straight at me to tell me that I should expect some sort of a limitation, that I should expect y going to infinity. So most of these things come as a surprise that there is in fact a limit to the interval of existence, and that's a big deal. That's what differentiates linear from nonlinear cases. So you see what's the reason for that terminology, that we separate one group of equations from another group of equations. So we expect some complications here. Let's go ahead. We have chosen some differential equation that we can actually solve, and we actually can look at the interval of existence from the theoretical solution. More often than not, we cannot do that, and we have to just keep ourselves happy with some qualitative answer from the software or some equivalent thing. So let's go ahead. First one, I pick y prime is equal to, y prime is equal to 2ty squared. So this is problem A from our list. Let's separate our problems from our solutions. Okay. Now all of these problems are, let me ask you to tell me quickly what's the method of solution we are going to apply to these things. Okay, you have like 2 seconds to answer what method of solution applies to all of these problems. Did you figure that out? Yes. All of these are separable. So let's go ahead and separate them. So this dy dt is equal to 2ty squared. So I rearrange it, so it becomes dy y squared is equal to 2t dt. Now we are in a position to actually integrate both sides. That's what's nice about separation. So the first one, antiderivative of this, again you have 2 seconds. Tell me what's the antiderivative of dy over y squared. Okay, stop that and stop the video and try to quickly figure out what this is going to be. Okay, so it's minus 1 over y. The right hand side definitely would not have any issues with that. That's going to be t squared plus c. C is some constant. Now in all of these problems we are expected to give our final answer in terms of the initial condition. So let's go ahead and enforce our initial condition, meaning let's figure out what this constant is going to be if they tell us that at 0 our graph is supposed to pass through y0. So I go ahead, so this means when t is set equal to 0, y should be equal to y0. So I go ahead and instead of t I put 0, and instead of y I put y0. Obviously in all of this, all of our y's should be different from 0. This cannot be 0 because there would be an issue here, and of course the integral would not have made sense, so we are staying away from 0. So at any rate, so we get our constant to be minus 1 over y0. We go ahead, this is a very crucial step, to replace your constant by a function of y0. So I go ahead here, I have minus 1 over y is equal to I have t squared and then minus y0. Next question, crucial question, what is y equal to? We don't want 1 over y or negative 1 over y, we want y itself. So go ahead, and again now you have 10 seconds to tell me what y is. Carefully do the algebras needed to find out what y will be equal to. Okay, now many students have a bit of a hard time with fractions and such, and typically they end up thinking that if I flip this, I can take this, flip that, and flip that individually, and I'll get my y. Well, that is incorrect. If you did that, make sure you brush up on your algebra and get this thing correct. So what's the, let's go step by step. I write minus 1 over y. I have to take a common denominator here, so y0. So denominator here will be 1. And cross multiply these two, get y0 t squared, and then minus 1. Now I have one fraction is equal to another fraction. And now it is legitimate to flip both of them. So I'll have y over 1 now is negative, and the other side is also y0 over y0 t squared minus 1. So I have a minus here. Let's take it to the other side, and also it's not nice to have a 1 in a denominator. Kick that out. So I'll have y is equal to y0. We write our answer with the fewest possible characters. That would be our final answer. Okay, so step 1, what's the solution? Here is the solution. Step 2, what is the domain of existence of our solution? What's the issue here? Why should the solution stop at any particular time? Let's go slow. Let's assume y0 is some number so that we are in a more familiar terrain. So suppose, say y0 is 4. Then our solution would have been 4 over 1 minus 4t squared. Now you definitely remember from pre-calculus that this function has a specific domain, and it's one of the pieces of that domain that's going to be our domain of existence. What's the issue with this? Well, of course, when 1 minus 4t squared becomes 0, you will be dividing by 0, you get infinity. So this is going to happen when t squared is 1 over 4, which of course is going to happen at t is equal to plus or minus 1/2. So in pre-calculus, you will say the domain of this function is any number other than plus or minus 1/2. But as we said some lectures a while back, is that in differential equation, the point of view is different. So if I have in pre-calculus, if I'm excluding these 2 points from my solution, in differential equation, I have to make it more clear. Which one of these regions do I want? This one, or this one, or that one? So one of the 3 is going to be picked up. In pre-calculus, all 3 of them are fair game. Here, the picking is going to happen according to where your original initial condition is. If your initial condition is at t0, then that interval is going to be picked. So out of these 3, this is the one that's going to be picked. So for this particular case, my t is going to be limited from minus 1/2 to 1/2. If y0 were 4, my domain of existence would have been between 1/2 and minus 1/2. Now let's up the ante. Suppose I want you to find out the answer regardless of what y0 is. I don't want to pick a particular case, rather I want to answer for all possible cases. So now I'll give you like 3-4 minutes. You have to think a little bit more carefully to tell me. So I want you to tell me for any y0 what is on the right hand side and what's on the left hand side of this inequality. That would have been the domain of existence. And there's a little bit of extra fine print that you need to pay attention to. So again, pause this video and try to answer it yourself. Okay, so no peeking. You are going to try to do it by yourself. Essentially, the trick is that whatever you were doing like this in high school algebra and such, now you have to push yourself to elevate yourself to the parametric version of this. Instead of sticking to numbers that are comfortable to you, you have to move one level higher up to a parameter where this is a specific instance of that. So we do the same thing essentially. It says 1 minus y0 t squared is equal to 0. We solve this thing. So 1 is equal to y0 t squared. I divide by y0. We are trying to find t. So it's customary to write what we want to find on the left and what we are finding it in terms of on the right. So now I go ahead, take my root, and that is where my plus or minus comes in. Right away, we pay attention to something. If y0 were negative, this would not be legitimate for us because this is a complex number. So going this stage, we are going to be assuming that y0 is positive. If so, then my domain of existence is between the positive and negative of this root. So the answer would be t is less than 1 over y0 in root, or larger than negative of the same thing. So this is one piece of the answer. So you'll be asking, is there another piece? Well, I'll be asking you that question. What's the other piece of the answer? What else is it that is missing from this picture? Okay, so for example, if y0 were 4, my answer would have been between a half and minus a half. That's my domain of existence. What is it that we are missing? Well, it's clear from here. What if y0 were negative? Or what if y0 were 0? Well, let's go after the negative case. If it is negative, if y0 is negative, let's write an example so it's clear. Suppose y0 is minus 4. Then my y is going to be minus 4 over minus 4 over 1 plus 4t squared. Well, this denominator is always safe. It's never becoming 0. So the domain of this thing is all numbers from minus infinity to infinity. Does that ring a bell? Do you remember what happened on the very first slide that we had here? If you have a negative starting value, your domain is from minus infinity to plus infinity. Everything is fair game. If you are on the positive side, then your domain is from some specific number to a negative of that number. What is left? Well, what's left is in between. What if y was 0? If y0 is equal to 0, we can answer the problem in several ways. At the beginning, we excluded that. But if you start at 0, your slope will be 0 and you are permanently stuck at 0. Here's another way of seeing this thing. Luckily, our answer covers all bases. We don't need a separate answer. If y0 is 0, if this is 0, it doesn't matter what you got here. The answer is always 0. So that is clear. So if y0 is 0, our answer is for all times it is 0, and the domain of that is, well, there is no issue with having an answer 0. The domain is from minus infinity to infinity. So final answer, if y0, so we have two cases. If y0 is positive, or if y0 is negative or 0. This one, the answer was clear. From minus infinity to infinity, there is no limitation. This one, the interval that signified our interval of existence was from minus 1 over square root of y0 to 1 over square root of y0. So that was interval of existence. Okay, now you know what we are after. You know what we are after. So for each of these things, it's your option to go after the DField, get your feet wet with respect to how the answer looks like, what we are kind of after, and then come back and then give the exact theoretical answer. So in DField you see what it looks like, and here you get the exact formula. So let's go ahead, do another example. So perhaps I do 2 and you do the other 2. So our other equation was y prime, it's problem B, y prime is minus 4t over y. Okay, I fully expect to do that you do this problem entirely from beginning to end by yourself. First time around it could take a while, maybe even half an hour or something, but it's very important that you actually slug it through and try to rely on yourself, correct yourself, and it might be a bit of a challenge, but try to put all the pieces together and then come back and compare your answer versus what we have. So the entire thing, let's put that whole thing on your shoulder. You do the whole thing and then come back and then compare your answer little by little. If you made some partial progress, just on the video, go as far as that, and again try to jumpstart yourself and try to do the problem by yourself. Okay. So first, dy dt, Leibniz notation, minus 4t over y. So all of these things are done by separation. So y dy is minus 4t dt. So this looks a little bit easier than the previous one. It looks like I don't have much to worry about. Antiderivative of this is y squared over 2. Antiderivative of that one is minus 2t squared. Then I have a constant. We said the best place to apply the initial condition is as soon as the constant shows up. That's probably the easiest place to do this thing. So if time is replaced by 0, this has to be replaced by y0. So let's do that. So in the simple cases, c turns out to be just that applied at y0. So c is y0 squared over 2. So I rewrite my equation. Y squared over 2 is equal to minus 2t squared plus y0 squared over 2. Okay, so if you did if you listen to my advice and did the problem by yourself, this is a place at which you want to cross-check versus what you have done. If there was any issue, you want to make sure you understand what the mistake was and restart yourself. We are going to go to the next phase. Next phase is, well, what is y equal to? So I multiply by 2. And then I want to take square root. Okay, would it be correct if I just write this? Customary, we write the positive item first, negative item second. Is that it? Or are you going to correct me? I hope you do correct me that this is really plus or minus, and we have to choose which one of them is it. Well, how do we choose? The choice is always dictated by your initial condition. At time 0, we want to catch y0. So if y0 is a positive number, when t is 0, y will be y0 if I choose the plus. Otherwise, I have to choose the minus. So here is a more clear way of stating this. The answer is y0 squared minus 4t squared if y0 were positive. On the other hand, if you want to start at the negative spot, then you have to have that negative in front of this to conform to what you want. Well, you might ask, what if y0 were 0? Well, that is obviously not allowed because you'll end up dividing by 0. So this y0 here, under no circumstances would we want to have it 0. It wouldn't make good sense. Well, either of these things, what would be the domain of existence? So again, I'm hoping that I'm not boring you by repeating the same thing. You're supposed to stop here and make sure that you came this far by yourself. Okay, next issue is, what was the domain? If you are stuck on what is meant by that, go back to what we did there. We said, okay, the problem might look a little bit theoretical. Let me go ahead, pick an example. So I picked a number, figured out what the answer will be for that particular number, and then I come back and say, well, I want a general formula. I want to kill all the birds with one stone. I don't want to write a separate solution every case. I want to deal with all of them all at the same time. So here you can do the same thing. So if you are confused as to what to do, pick a number for y0. Like y0 say is 5 or 10 or something. And then find out what the domain will be. And then come back and generalize that to all y0s. So here I say, well, if I have square root, what do I expect from my radicand? The stuff in the radical has to be, of course, larger than 0, or maybe just equal to 0. Well, this tells you that y0 squared has to be larger than 4t squared. So what is the maximum value t can be? T can be as larger than y0, but we have to be careful about distinguishing between positive and negative cases. So t becomes as large as absolute value of y0, I have to divide by 4 and take square root, and as low as negative of that. So how far I go on the right and on the left are going to depend on how high I start. So that is going to be the answer to this problem. So that's a domain of existence. So let's write t turns out to be from minus absolute value of y0 over 2 all the way so let's go ahead and see this on our favorite software. Here we have, what did we have? Minus 4t over y, is that right? And then let's ask for the graph. I already graphed lots of, let me clear it so it took my surprise away. Why? Oh, this is the problem. I had to uncheck that so it wouldn't graph stuff for me. Well, remember, we are starting for all of these problems, we are starting on this y-axis. So if I start here, I have a certain distance to the right, to the left I can go, and that's my entire trip. That's my domain of existence from here to here. If I start high up, then my domain is bigger. Again, this is the situation very different from what we saw in the linear cases. In linear cases, if you go up or down, your domain did not change. Your domain did not depend on y0. Here it does. So, and well, if you go to negative, in this case, negative and positive have the same answer. Is the figure familiar to you? What is that shape? Okay, I should be able to answer that in a few seconds. What does this formula remind you of? Of course, from that figure, you say it's an ellipse, and of course, you see it here as well. If you take y squared and t squared to one side, that is a standard equation of ellipse you have seen in calculus or pre-calculus and such. Okay, so you go ahead and do the other two problems as well, and I'll perhaps post them to another video, and the time gap between these two videos, you convince yourself to go ahead and do them from scratch. The problem number 3 is a little bit lengthier than the others, and the number 4 is it's essentially very similar to 1 and 2. So until then, good luck and God bless.